So we decided to do X as the standard for that kind of system.
Wow, those are very large numbers. It's very impressive. Really a step function gain in efficiency that every CIO could benefit from. So you have to tell us what's next, what's on the dock.
So what we are evaluating now is, of course, cloud. So we have EXA as fast as one way to go, and SaaS when possible. We understand that SaaS is not 100% there, but we expect that by doing fast in the cloud, we can take another 30 to 50% cost through the process. So that's our next step.
Those are big and impressive numbers, and it takes strong leadership to drive this kind of change and get these kind of results. So I'm really thankful to you, and I'm very impressed with what you guys have achieved. Thanks, Ricardo. Good to see you. Share with you some of the new products that are coming from Intel that will continue to drive the efficiency of your cloud solutions. In our current world where data is the game changer, high performance and efficient computing is going to require advanced storage and memory technology. 3D NAND, as the latest storage media, focuses on both cost and capacity improvements. With the products that Intel will ship next year, 3D NAND will be capable of storing a terabyte of data in a 1.5 millimeter package and over 15 terabytes in a solid-state drive. The 3D XPoint, the next generation of storage technology coming from Intel, is the real game changer, and Oracle has been a huge partner in the early enabling of this. Their early performance data on Octane solid-state drives using the 3D XPoint technology shows a 10x gain in IOPS, huge, and a 12x reduction in latency compared to Intel's own 3D NAND solid-state drives. But the breakthrough of 3D XPoint technology really comes with its use as system memory. So it will displace traditional DRAM. 3D XPoint memory solution delivers twice the capacity of DRAM at far lower cost and at the same performance. It's a breakthrough for server apps that have large data sets and demand that high-speed execution. A perfect example, of course, being data analytics, an area of explosive opportunity for IT as IT identifies ways to use the data to inform the business. So today's 2-socket Xeon server supports up to 1.5 terabytes of DRAM. With the launch of 3D XPoint next year, we'll support up to 3 terabytes of memory at 30 to 50% lower cost. And Oracle will be obviously an early adopter of our 3D XPoint memory DIMMs as well. Over the past 7 years, bandwidth into the server has increased by 50x, going from 1 gig in 2009 to now 50 gig today. So traffic growth across the data center is creating a true network bottleneck. Today, that traffic across the data center is handled by traditional fiber optics. Optics is obviously required due to the reach and bandwidth, but fiber optics is expensive. Over 50% of the total network spend is on optics, and that percent is growing. So there is a clear need for a breakthrough in high-speed network interconnect. And so last month, after 16 years of development, starting in Intel's labs, we launched Intel Silicon Photonics. And Intel brings a clear advantage in optical interconnect. It is the only solution that builds the laser on the silicon. So we integrate the laser light emitting material, so indium phosphide, with silicon, and then we use the silicon lithography process to actually define the laser, to align the laser with precision. This delivers to IT a cost advantage, a performance advantage, which translates to longer reach, and a density advantage. So the first Intel Silicon Photonics is 100 gigabits per second, and it's targeted at the connection across the rows and across the data center. As the server network bandwidth increases from 10 gig to 25 gig and then to 50 gig, optics will actually also be required direct to the server. The existing electrical connections inside the rack will hit a brick wall when we get to 100 gig serial speeds. So we see a future where optical I/O is everywhere in the data center, and our ability to run optics on the silicon gives the IT world compelling and unique benefits, and we are shipping silicon photonics in production today. Earlier this year, we launched the next generation Xeon processor, the E5v4, and that's based on the Broadwell microarchitecture and 14 nanometer process technology. It delivers 22 cores, increased memory bandwidth, and impressive virtualization technology that again delivers a more efficient cloud solution. A huge benefit of the Xeon E5 product line is the fact that it delivers high performance across the full range of workloads. We're delivering up to 44% performance improvement over the prior generation of Xeon at the same power across compute, storage, and network workloads. Intel Xeon is the foundation of cloud computing. The cloud runs on Intel, and through our work with partners like Oracle and other leading enterprises, we've developed a deep understanding of the challenges that IT faces when trying to deploy a cloud that is both high-performing and highly efficient. So we've taken all that insight and we've driven features down into the silicon. With Xeon E5v4, we added a new feature called Intel Resource Director Technology, or RDT as we say, to solve the noisy neighbor problem. So, if you don't know what the noisy neighbor problem is, I'm going to tell you. Intel RTD is a set of silicon features that directs the cloud orchestrator. So it ensures that the application has all the resources that it needs in order to meet the SLA that has been committed by IT. And it does this by monitoring, controlling, and recording cache and memory usage. So I'll show you how it works using the on-die cache resource as the example. So in this example, before Intel RDT, the server's cache resources are allocated to the application that comes in first. So first serve. Allocation is independent of what the application's SLA might be and what the performance requirements of that application might be. So this allows the creation of the noisy neighbor. With RDT deployed, the cloud orchestration solution has the ability to bound the cache resource and create priority amongst the virtualized applications. So a high priority app, the green app in this case, has priority access to the cache and can deliver the performance and the SLA that IT is committed to the line of business. When your high priority app is sitting idle, the lower priority app, orange in this case, can then expand its access to resources and run at higher performance. When no one else is home, the neighbor can be as noisy as it wants. But when the needs of the high priority app then increase, the RDT feature will automatically evict the lower priority app from the cache. So this is a nice little cartoon, but it is incredibly valuable in increasing the utilization of your infrastructure while meeting the performance commitments. You no longer have to over-provision your infrastructure, as we all do, in order to meet the SLAs. It is also a key and critical feature to support the move of your network from fixed function appliances onto network function virtualization. So RDT will ensure that you're able to maintain your packet processing, quality of service requirements, while also deploying new features and services like intrusion detection and prevention on that same infrastructure running on Intel-based servers. Oracle consistently leads in the adoption of next-generation technology to continue that commitment of delivering the very best optimized solutions for enterprise. And the wonderful thing about Oracle is they provide choice. They provide their customers with both a premium performance experience on-premise and a premium experience through the Oracle Cloud. Last year, we jointly announced Project Apollo, and this was an Oracle-Intel joint engineering program to optimize Oracle Cloud using Intel technology. Thomas Kurian, Oracle's President of Product Development, planned to be here with me tonight on stage, but unfortunately is aiding a family member with a medical situation, and I'm very grateful to him, though, for being able to make this video and share his thoughts with you on our partnership and the team's progress. So let's see the video.
Thank you, Diane. Happy to be here to share our progress. I'm sorry I can't be with all of you in person. Last year, we announced Project Apollo, a joint program and lab that enables Intel and Oracle experts to work together to optimize real cloud workloads in a scale-out data center environment. We started by optimizing performance and variability for Java as a service, and we were very encouraged by the results. This year, we expanded our collaboration to workloads beyond Java to include database as a service, big data as a service, and software as a service for our applications. And we've seen fantastic results. For example, in human capital management, software as a service, Intel and Oracle collaborated on software optimization for the new generation of Xeon processors, and we delivered an incremental 1.8 times performance improvement. This is a great example of Intel hardware and Oracle software working better together. In addition to performance optimizations, we've also collaborated closely to utilize Intel cloud technologies in our own data centers through the deployment of Intel Resource Director technology. Through experiments where we ran multiple workloads together in Oracle's cloud data center environments, we have shown that RDT delivers up to 52% better performance for throughput applications. In addition, we've seen a 4 times improvement in application response time and up to a 3 times reduction in variability of response time. We will continue implementing Intel RDT and other Intel cloud technologies in our own environment. And ultimately, we'll extend these technologies into our products so our shared customers can benefit from them as well. We look forward to a continued partnership between Oracle and Intel. Diane, thanks once again.
Yeah, So thanks to the pervasive reach of cloud computing and the increased availability of connected devices, we have millions of terabytes of data that are now being generated every day. Whether you call it big data, data analytics, machine learning, artificial intelligence, this is the big buzz in our industry. So the question is, why now? I mean, heck, we've been talking about artificial intelligence since the 50s. So there's 3 big enablers to the why now. Number 1, it starts with cloud computing. It is a fundamentally more efficient way to connect and deliver services. Number 2, it's pervasive connectivity. Secure connectivity can be assumed, and it will continue to improve in the move to 5G. And number 3, at the foundation is Moore's Law. Cost efficiency of technology. Over the past decade, the cost of servers has declined 40% and the cost of storage has declined over 90%. It is now cost feasible to store and compute on massive, massive amounts of data. And all of this has then brought on a tremendous investment in the algorithms and techniques, both in academia and in the commercial space. Massive amounts of data enables tremendous opportunity. We are reaching the tipping point where data is the game changer. It is the differentiator for business. And while the phrase artificial intelligence often summons up visions of great science fiction, it isn't relegated to novels and movies any longer. Artificial intelligence is all around us, from the commonplace talk-to-text or photo tagging, fraud detection, to the cutting-edge precision medicine or injury prediction in sports or autonomous vehicles. Encompassing compute models from business intelligence to data analytics to natural language processing to machine learning, artificial intelligence is transforming the way businesses operate and how people engage with the world. And while enterprise IT may have been slow in the adoption of cloud computing, our collective goal should be to ensure that enterprise seizes the opportunity that artificial intelligence brings to the business. In fact, many large businesses are already benefiting from the insights of data and artificial intelligence. They are transforming. And a great example is UPS. So UPS saw analytics as a key differentiator opportunity in their journey for operational improvement. UPS delivers more than 20 million packages every day. And so rather than leave the route to the decision of the driver, they knew that if they could optimize the route, shaving just 1 mile per driver per day off the day's route, it would translate to a savings of $50 million a year, bottom line savings. So UPS created their integrated optimized navigation system codenamed Orion. Orion uses expansive fleet telemetry and advanced analytics to gather data and calculate countless amounts of data to provide the UPS drivers with that optimized route. UPS was able to reduce 85 million miles last year, equating to over 8 million gallons of fuel and a reduction in carbon emissions of over 6,500 tons. So transportation, an industry founded centuries ago, transformed by data. For the wide range of artificial intelligence solutions, Intel is the optimal platform. I certainly believe that. There is a tremendous benefit in running on Intel architecture. A common and consistent programming platform and model is key, whether you're building or training your data model, whether you're scoring that model across real-time events, whether you're running a scale-up in-memory analytics solution, or whether you're running a scale-out Hadoop solution. You want to have a common development platform, and you want it to match the deployment environment. So for scale-up solutions, we provide leadership with Xeon E7 and Xeon 5. For big data scale-out solutions, the platform is Xeon E5 with Hadoop. Machine learning and its subset technique, deep learning, which gets a lot of buzz lately, runs best on a combination of Intel Xeon Phi and Intel Xeon. It is the most widely deployed processor solution for both machine learning and deep learning. I have to say, machine learning and deep learning, by definition, is a distributed, parallel, high-performance workload. The math for deep learning is not complex. It's simply linear algebra. We all passed that, hopefully, back in Algebra 2 in high school. But what's new and what gets the buzz is the enormous scale. So the more data you can compute, the more accurate the model you'll get, and the more compute capacity that you have, the faster you're going to be able to train that model. So Intel architecture inherently scales. It scales as the model grows. And Oracle Exadata is a very high-performance in-memory database machine. It offers all of the enterprise features, of course, including features like security. Exadata runs all of the database workloads, OLTP, data warehousing, in-memory analytics, as well as a consolidation of mixed workloads. And the rapid success of Oracle's Exadata engineered solution reinforces the increasing value of data to the business. I'm happy to say, of course, that Exadata is built on Intel's latest Xeon E5 v4 processor and optimized through a very tight partnership between our engineering teams and the Oracle engineering teams, and is also now offered in Oracle Cloud with all the same extreme performance and availability that's offered in the on-premise solution. One of the most exciting and forward-thinking uses of data analytics is the application to the sporting world. And Oracle has been a leader in this space, applying analytics to the performance of Oracle Team USA, the champions of the 2013 America's Cup. And they are set to defend their title next year. And it's no surprise, then, that they would be relying on cutting-edge technology to give them a leg up. Let's take a look.
The America's Cup is the hardest event to win in the world of sports, in my opinion. You have to be better than the opposition in every facet of the sport, be it the design of the boat, the way the crew sails, the tactics. So we're looking for that little bit extra, that extra 5 or 10% that we think this type of data collection can offer. By tuning those training programs, the guys are going to be as good or better than any other team out there. Thanks to Intel and our relationship with them, we've been able to get access to a giant supercomputer. It's able to model all of the dynamics of the hydrofoils, the foils that lift the boat out of the water. And by modeling it more accurately, modeling it with more fidelity, we get the best answers, hopefully better than our opposition. It's no secret that the fastest boat is the product of the best technology, but it's not just down to supercomputing. We have the crew instrumented daily. They wear hard straps and wrist devices that have powered by Intel processors that actually feed back real-time data of the crew's performance, be it on the water, in training, even while they sleep. We're measuring their power output on the winches. We measure their heart rate, their respiration, their perspiration. We measure every detail of their physiology all the time, because by monitoring the crew and seeing how they're doing in training, seeing how they're doing in racing, and seeing how they're doing in recovery, we're able to tune the training programs to make sure they're at peak level on the day of racing, and that's what it's all about. The final America's Cup race is going to come down to a matter of a percent or a fraction of a percent, and the crew performance is one thing that we can tune right to the very end, and with our approach, with the help of Intel, we're going to get there and we're going to have the best crew on the day.
Servers are boring. That is exciting. And I am super excited to have members of the Oracle Team USA with me here to share more about their historic run. So please welcome Ian Burns, aka Fresh, Director of the Performance Analysis Group, and Kurt Jordan, the main structural designer for Oracle Team USA. Thank you. Hi, good to see you. Thanks for joining me. So that video was incredibly exhilarating. That was a lot of fun. So before we get started, you first have to tell me how you got the nickname Fresh.
We have some secrets in the America's Cup, Diane, and that is one of them. Tell that story.
Really? You're not going to say anything?
Not in public.
Okay, quickly move to the next question. So next question then. So Kurt, can you just give us all, I mean, this is so amazing. Give us all a little feel for what it's like to actually be in the America's Cup and the demands of the race, demands on achieving peak performance both for the boat and for the folks, for the crew?
Yeah, Diane, I'd love to. The America's Cup is the pinnacle event in yacht racing. It pits the best designers and the best sailors in the world against each other in a competition where every performance feature can be the deciding factor in yacht racing. One really good example is that in the Cup, these boats fly above the water almost the entire time, supported by carbon fiber foils. The design of these foils is wide open to all the teams, and we'll expect some very unique solutions of the other teams here in the racing. To simulate sailing conditions, high-fidelity computer models of the fluid flow over these foils are employed by our design team to characterize the behavior of these foils. And the behavior meaning the performance of the lift and the drag and the stability of these foils in the water. We run these very large computer simulation models on Oracle Exadata technology. The configuration is a single rack with 30 nodes of Intel's Xeon E5 processors. This technology has allowed us to run extremely large analytical simulations. The model sizes have grown from about 1.5 million elements in 2007 to upwards of 30 million elements today. The optimized foil designs literally allow these boats to fly above the water in almost all conditions. But when they don't, the boats can splash down into the water, and one incident of this can cost about tens of meters around the race course. And this is in racing that sometimes the margins are just a few seconds.
It is absolutely amazing. The amount of simulation that goes into making sure it never does hit down. A lot of pressure there. So in the video, I actually saw that the guys had on wearables, and I'm assuming it's not just for a fashion statement. So maybe Ian, you can, or Fresh, maybe you can tell me a little bit about those wearable devices.
Well, apart from the fashion statement, it's also crucial that the energy the guys output is actually at an optimum. All of the power on the boat comes from guys grinding the wind channels round and round, and that is a critical part of the performance of the boat. So we monitor closely 24/7 all sorts of things, the heart rates of the guys, the power output, their respiration, their perspiration, all of these things are uploaded up to the cloud, analysed on Intel Xeon processors, and from this information our trainers can actually look at the individuals as a whole person. They can look at how much sleep they're getting, what their recovery is like, how much power they output on the boat while they're sailing. And from that information they can tailor a perfect program to develop this crew to the absolute optimum. To give you an idea, each guy puts out about 350 watts throughout the whole race. The boat needs about 450 watts per man to actually sail at its optimum. So our goal right now, between now and the America's Cup, is to actually lift the guys about 100 watts each, and that's what this technology will deliver.
Sounds extremely intense. So all of this is incredible, and I appreciate you being here. I guarantee that Intel's going to do our part to give you the latest and greatest technology to help you extract that additional performance out of that crew and the boat. And I just want you to know all of Team Intel will be rooting for you in Bermuda to win next year.
Well, thank you so much, and thank you, Intel. But while you're cheering us on, we've got a little something that you can wear while you're doing that. Some little jacket for you to wear while you're cheering us. This is Kai Hurst, one of our grinders of the sailing team. And how are you? On behalf of the Oracle Senior, I would love to present this jacket for you.
Thank you. Much better than what I'm wearing, huh? So I actually obviously appreciate this night. I have to say though, I actually had the same idea. I thought that maybe when you guys were racing in Bermuda, that you would be willing to wear the Intel swirl, and I actually didn't wear it not at all.
Thank you. Perfect. Thank you so much.
Thank you. We'll get a little photo up there. Thank you. It is really an honor to have you on stage. Thank you for sharing. You are the big data picture perfect opportunity. Thank you for sharing. Good to meet you.
Thank you.
And good luck. Boy, race is on, huh? So I hope that all of you see that it is a very exciting time for enterprise. The expanding role of IT enables new opportunities for business growth. It happens for three reasons. Number one, the investment in both public and private cloud enables efficient and flexible delivery of new services and new business models. Number two, the rapidly advancing data analytic solutions are creating new business insights and enabling new action. And three, data is the game changer, and I truly believe AI will transform the way all businesses operate. The technology innovations from Intel and Oracle and our partners are creating and delivering the next wave of enterprise opportunity, and I hope you all seize that opportunity. Thank you very much.